Welcome to the video on continuity, limits, and higher derivatives. So first we'll talk about continuity versus differentiability. A function f of x is continuous at x equals a if all three of these conditions are met. If f of a is defined, if the limit as x approaches a exists, and if the limit as x approaches a of f of x is equal to f of a. So if we have some function and then there's a value a, your values coming towards it from both sides, your limits from both sides, have to be the same as the point there. For a function to be differentiable, f of x needs to be continuous and there can't be any sharp cusps or peaks. So here, for the absolute value of x, the function is defined at every point, and at 0, if we look here, our limit from the left and from the right is going to be equal to 0, and our point there is also 0. So it's continuous there, but it's not going to be differentiable because you can't take a derivative there because your slope is different from both sides. So here we have negative x, and here we have positive x. So you can't take the derivative at 0. So it's not differentiable. All differentiable functions will be continuous, but not all continuous functions will be differentiable. So next we have convergence versus divergence. You'll have a convergent limit if the function gets closer and closer to a finite number as x approaches negative or positive infinity. So it would be convergent if it gets closer and closer to some number, like 4, for example. So if your limit as x approaches infinity of f of x plus 1 over f of x is less than 1, then you have a convergent function. You have a divergent limit if the function does not approach one value as x approaches negative or positive infinity. Typically, a divergent function will go to negative or positive infinity. So this is when the limit of f of x plus 1 over f of x is greater than 1. So it would look something like this. It could go to infinity, it could go to negative infinity. These would have to be separate functions. But it would look something like that. So now we have the definition of a derivative, and we have it using limits. So a derivative, f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So here for this example, it says find the derivative of f of x equals x cubed minus 3x plus 4 using the definition of derivatives. So our f prime of x will equal the limit as h approaches 0 of f of x plus h. So every time it says x, we'll put x plus h. So we have x plus h cubed minus 3x plus h plus 4. So there's your f of x plus h minus your f of x, which is x cubed minus 3x plus 4 all over h. So we'll start by figuring out what x plus h cubed is expanded using our binomial theorem, which says that x plus y to the nth power equals the sum from r equals 0 to n of n choose r times x to the n minus r times y to the n. So our x plus h cubed is 3 choose 0 of x cubed times h to the 0 plus 3 choose 1 x squared h to the first plus 3 choose 2 x to the first h squared plus 3 choose 3 x to the 0 h to the 3. So 3 choose 0 is 1, h to the 0 is 1, 3 choose 1 is 3, 3 choose 2 is 3, 3 choose 3 is 1, and x to the 0 is 1. So x plus h cubed equals x cubed plus 3x squared h plus 3xh squared plus h cubed. So this will equal the limit as h approaches 0 of x cubed plus 3x squared h plus 3x h squared plus h cubed minus, we have 3 times x minus 3 times h plus 4, and then we have minus x cubed plus 3x and minus 4 all over h. So this x cubed minus x cubed will be 0. And then we have negative 3x and positive 3x, so that's 0. And plus 4 and minus 4, that's 0. So then we can divide everything by h. So we divide h. That will become to the first power. That will become squared. And that's just 3. And that gets rid of that h. So we have the limit as h approaches 0 of 3x squared plus 3xh plus h squared minus 3. So if h goes to 0, then this will go to 0, and this will go to 0. So it will equal 3x squared minus 3. So f prime of x equals 3x squared minus 3. And we can check that with our power rule. So f of x was x cubed minus 3x plus 4. So we'd have 3 times 1, which is 3x. We'd lower the degree to squared. And then minus 3 times 1, which was negative 3. And then if we lower the degree, we just get x to the 0, which is 1. So f prime of x equals 3x squared minus 3, which is what this gave us as well. So for higher derivatives, your higher order derivatives can be expressed in the form of d to the n y over dx to the n, or f to the n of x, where n represents the nth derivative. So if you wanted the 10th derivative, you would say d10y over dx to the 10, or you could say f10 of n, so the 10th derivative. So here we have our first IB practice question, which is no calculator. It says, are the following functions continuous, differentiable, both, or neither? So this first function, if you followed along the entire function, you never have to lift your finger up, which means the function is continuous. But if we wanted to know if it's differentiable, we'd look if it's continuous, which it is, and then we'd have to check if it has any sharp cusps or points. You can see here there's a point where the slope changes, and then here the slope changes dramatically, and then here's another one, so it's not differentiable. So this one is just continuous. This second one here, you could run your finger along the entire function without picking it up. So it's continuous. There are also no sharp cusps or points, so it's also differentiable, which means it is both. For part C, you can run your finger along the entire function. So it looks like we have a quadratic and then a linear function, but it's continuous. And it looks like our slope is the same at this point. So there's no sharp point or anything. So it's also differentiable, which means it is both. This function, you would go from here to here, then you would jump to this point and come back all the way up and then jump down here. So since you're jumping around, it's not continuous. And because it's not continuous, it automatically cannot be differentiable. So it's not differentiable, which means it is neither. So there's no possible way that your answer would just be differentiable, because if it's differentiable, it means it also has to be continuous. So here we have our second IB practice question. It says find d cubed y over dx cubed. So this means we need to find our third derivative. Using the definition of derivatives, if y equals 2x squared minus 5x plus 3, and then does the function converge or diverge? So we have to use our definition of derivatives. So f prime of x equals the limit as h approaches 0 of f of x plus h. So we have 2 times x plus h squared minus 5 times x plus h plus 3 minus our f of x, which is 2x squared minus 5x plus 3, all over h. So this equals the limit as h approaches 0 of 2 times x squared plus 2xh plus h squared minus 5x minus 5h plus 3 minus 2x squared plus 5x minus 3 all over h. So we have a minus 5x and a plus 5x, a plus 3 and a minus 3. We're going to have 2x squared, 4xh, and 2h squared. So we'll have a negative 2x squared and a positive 2x squared. So this equals the limit as h approaches 0 of 4xh plus 2h squared minus 5h all over h. And if we divide an h from the numerator and denominator, we get rid of that h. That becomes first, and that becomes nothing. So we have the limit as h approaches 0 of 4x plus 2h minus 5. So if h goes to 0, this will become 0. So our derivative is 4x minus 5. So f prime of x equals dy dx, which is 4x minus 5. So there's our first derivative. So now we need to do our second derivative. F double prime of x equals the limit as h approaches 0 of this new function of x plus h, so 4 times x plus h minus 5 minus our f of x, which is 4x minus 5, all over h. So this equals the limit as h approaches 0 of 4x plus 4h minus 5 minus 4x plus 5. So our plus 4x and minus 4x will cancel each other. Our negative 5 and our positive 5 will cancel. And it's all over h, and our h's will cancel each other. So our answer here is just going to be 4. So f double prime of x is d squared y dx squared, and that's equal to 4. So we need the third derivative, so we'll do this one more time. So we have f triple prime of x equals the limit as h approaches 0 of f of x plus h. So since there's no x in our function, it's just going to be 4 minus f of x, which is just 4, over h. So this is going to equal 0 over 0, which would be undefined. But if we think about as h gets closer and closer to 0, it's going to gradually get closer and closer to 0. So we'll say that f triple prime of x equals d cubed y dx cubed, which equals 0. So that is our third derivative, which makes sense because if we use our power rule for 2x squared minus 5x plus 3, The derivative of that would be 4x to the first minus 5x to the 0, so minus 5. And then the derivative of that would just be 4x to the 0, which is just 4, and the derivative of a constant is 0. So that's how we could double check our work on this one. So in summary, a function f of x is continuous at x equals a if f of a is defined, the limit as x approaches a of f of x exists, and the limit as x approaches a of f of x equals f of a. A function f of x is differentiable if f of x is continuous and there are no sharp cusps or peaks. For a convergent limit, the function gets closer and closer to a finite number as x approaches negative or positive infinity, and this limit is less than 1. For a divergent limit, the function does not approach one value as x approaches negative or positive infinity. Typically, a divergent function goes to negative or positive infinity, and your limit would be greater than 1. The definition of a derivative using limits is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. And higher order derivatives can be written as d to the n y over dx to the n, or f to the n of x, where n represents the nth derivative. That's all for this video. Thank you for watching.